All right, let's dive right in. Today, we're putting on our detective hats to tackle a really critical skill in data science, exploratory data analysis, or what everyone just calls EDA. So what is it, and why should you care? Well, let's get into it. So you might be thinking this is the setup for a cheesy joke, but seriously, the answer is pretty much everything. Think about it. Before a detective can crack a case, what do they have to do? They've got to survey the scene, they have to gather all the evidence, and they have to start looking for clues. And that, right there, is exactly what EDA is all about. It's the critical detective work you do before you even think about jumping to conclusions or, building some complex AI model. You have to get in there, survey the data scene, and really understand what you're working with. Skipping this part, that's like trying to solve a mystery without ever even visiting the crime scene. It just doesn't work. Now, every good detective needs their toolkit, right? Well, in the world of data, our toolkit is going to be built with Python. So let's take a look at the absolute must-have gear for cracking any data case. First up, you've got Pandas. This is like our digital case file. It lets us open up our data, organize it, and just generally manage all the evidence. Then we have Matplotlib. Think of this as our trusty sketch artist, perfect for whipping up some quick, basic charts. But when we want to create some really stunning, compelling visuals, we bring in the specialist, Seaborn. This is our professional crime scene photographer, making our insights look sharp and beautiful with way less effort. Okay, so with our tools ready to go, it's time to open up the case file. For this explainer, we're going to be investigating a data set on student performance. And our mission, if you choose to accept it, is to figure out what factors actually lead to a good final grade. The very first question any detective asks when they arrive on the scene is simply, okay, what am I dealing with here? We need that basic sanity check. Are the columns what we think they are? Are we looking at 10 records, or is it 10 million? So in Python, we use two really simple commands for this first glance. df.head gives us a quick peek at the first few rows of our data, kind of like a detective getting a first look at the evidence log. And then df.shape, that just tells us the dimensions of our data set, how many rows of evidence, and how many columns of info that we have to play with. And here we go, our first set of clues. We can see our 4 key variables, or maybe we should call them our suspects: study hours, sleep hours, attendance, and of course, final grade. The shape tells us we're dealing with a pretty small scene here, just 10 records and 4 columns of evidence. Nice and manageable. All right, next up is something that is absolutely crucial. We've got to check if any of our evidence is missing. See, just like a detective can't work with a smudged fingerprint, a computer really, really hates empty cells, or what we call null values. We have to know if there are any gaps. The command for this is df.isNull.sum. This is basically our digital forensics tool. It meticulously scans every single column in our case file, searching for any missing information. And then it just gives us a simple count of any empty spots it found. It's a vital step for making sure our evidence is solid. And the report's in. 0 missing values. All clean across the board. This is fantastic news. It means our case file is complete. We don't have to worry about trying to fill in any gaps in our evidence. We can just move on. So, we've secured the scene and we've confirmed that all our evidence is intact. Now it's time to start the interrogation. But this is a visual interrogation. We're going to start creating charts to basically make our data talk and reveal its hidden secrets. Okay, our first visual question is all about the main outcome, the final grade. What's the general story here? Are most of the students getting great grades? Or are the scores all over the place? We need to understand the distribution. For this job, our go-to tool is the histogram. Now, just think of it like this. We're sorting all the grades into different buckets, or what we call bins, and then we're just counting how many students fall into each bucket. The command sns.histplot does all this for us, and it looks great. Now, take a look at the story this is telling us. You can immediately see a big cluster of students, 5 of them, scoring really high, up in the 85 to 95 range. But notice that on the other end, we've got a couple of students who are really struggling. This is our first real lead in this case. What's causing that difference? Well, this leads us to the most obvious question, right? We probably have a hunch that studying more leads to better grades, but a good detective never, ever assumes. We need to actually see the evidence. And the perfect tool for comparing two things like this is a scatter plot. What it does is simple. It plots every single student as a dot. Their study hours determine the horizontal position, and their final grade determines the vertical position. And there it is, clear as day. Look at that pattern. The dots are clearly forming a line that's moving up and to the right. What that means is, as one value, study hours, goes up, the other value, final grade, tends to go up with it. This is a classic textbook example of a positive correlation, and it's a huge clue in our investigation. Now, a good investigation also means looking for things that just don't fit, the unusual witnesses. In data terms, we call these outliers. An outlier is just a data point that is so different from everything else that it makes you suspicious. It could be a really unique case, or, hey, it could just be a typo. To spot these weird data points, we use a box plot. This chart is awesome because it quickly shows us the normal range of our data inside a box, and then it flags any points that fall way, way outside that range as little individual dots. It makes them super easy to see. So, in our case, the box plot for sleep hours comes back totally clean. Every single data point is right there inside the expected range. This is great because it tells us we don't have any impossible data, like a student who somehow studied for 100 hours in a single day. Our evidence is reliable. Okay, we've gone through the evidence piece by piece. We've checked out distributions, we've looked at relationships, and we've hunted for outliers. Now, it's time for the big reveal. This is where we put all the clues together in one single, powerful picture. This is it, the final question of our investigation. We know that study hours and grades are connected, but how do they relate to everything else? What about sleep and attendance? How do all our variables interact with each other at the same time? For this, we're going to unleash our most powerful tool, the correlation heat map. This command calculates the correlation, which is just a fancy statistical number that tells us how strongly two things are related. It does this for every single pair of variables in our data, and then shows us the results in a really easy-to-read, color-coded grid. And here it is, the big reveal. This one grid pretty much summarizes our entire investigation. You want to look for the brightest, hottest colors. So check out that square where study hours and final grade cross paths. It's bright red and it's got a number, 0.98. Now, a 1.0 would be a perfect relationship. So 0.98, that tells us the connection between these two is incredibly strong. So the heat map confirms it. That hot red color is our smoking gun. It shows a powerful positive correlation between study hours and final grades. As one goes up, the other almost always goes up too. This single visual basically wraps up our entire investigation. Case closed. And that really brings us to the most important takeaway here. The whole point of this process is to be a detective, not a lawyer. Think about it. A lawyer starts with the conclusion and then goes looking for evidence to back it up. A detective starts with the evidence and follows it wherever it leads. That's the mindset of great data analysis. So next time you get a data set, remember to put on your detective hat and just let the data tell you its story.